4, t equal to 4, you got your vertex. But I don't think I needed that. I just did this. Obviously, if it hit at 2 here and it hit at 6 here, halfway between it's going to hit its what? Lowest point. Does that sound good? Is everyone okay with this? And by the way, I say we sketch this out to t equal to, you might say infinity. How about for 0 less than or equal to t, and let's go up to like 10. So what would this thing keep doing? Keep going up. Here we go. I mean, it gets pretty high at 10. Remember, this is the velocity of a particle. So do you notice something? Velocity can be positive and velocity can be what?
Negative.
Negative. Now if it was me moving, let's say this is describing me. Velocity is positive when I move to the right. Wait, you're looking at me, so I better go this way, huh? Shame on me. All right, let me go this. Velocity is positive when I move to the right. Stop, I turn around, my velocity is 0. When I move to the left, my velocity goes what? Negative. It's just objects, particles that move like this. Or maybe up and down. Does that make sense? I throw up the chalk, it had negative velocity on the return path. If I went like this, then like this, it smells like an ant, positive negative velocity. Cool? Yeah, all right. So there's the velocity graph. All right. The next thing is, you're going to use this to answer a question. Use this graph. It was made for a reason. Letter C. When is the particle at rest? Use your graph to see this. When is the particle at rest?
So v equals to 0, right?
You know, particle at rest, everyone, that means time, or excuse me, not time, velocity, your velocity is 0. The particle's at rest. The velocity is, you look at the graph, when was velocity 0?
2 and 6.
Now, this is your velocity graph. This is your velocity function. This is v of t. When was it at rest? When was velocity 0? At 2 seconds? When else? 6 seconds. Anybody agree? It's almost like this. If this was me, let's say this is me. Ready? During the first 2 seconds, I ran to the right. 1,000, 2,000, stop. Because my velocity is what? 0. I stop, turn around, I have a look. I'm not moving. My velocity is what? 0. But then I moved in that direction. 3, 4, 5, 6 seconds. I stop. Now I'm moving what? Back this way. Does that make sense? But when was I at rest? When my velocity was 0 at rest, the answer? What do you want to put? T equal to?
2 seconds.
2 and what else?
6 seconds.
What is that supposed to be? 0 is less than t, is less than 10?
What's that?
Okay.
Good thing. Great job with this. I have a letter D. When is the move? Oh, you're going to get this because you just saw my movement. When is the particle moving in a positive direction? You're going to write as an interval. When is the particle
When t is
moving in a positive direction?
When t is greater than 6. Between 6 and 10, right?
All right. You're going to look at this graph, everyone. And whenever you see that graph above the x-axis, that's when it's moving in a positive direction. And remember me moving? I was moving in a positive direction that way. I was moving in a negative direction that way. So remember, I was like 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000. So when was I moving in a positive direction? From time equals 0 to time equal to 2. Well, what else? You can use open parentheses for your interval. Union, when else?
6 to infinity.
6 to infinity.
Or
Since
10.
I said only about the 10,
So,
I'll put 10. But let's say, like Kayla, let's say you wrote infinity here on your test. So I was writing wrong. I know she's got it. She knows if this went on infinitely, that's what would it be. But they did just do some particle from 0 to 10.
I have a question.
Sure.
First of all, on the 10, it should be a square bracket, right? Next to
You mean closed bracket?
close bracket, yeah.
I'm going to keep it open. If you want to, you could.
Okay.
That's a good question.
And second question is, that is a declining slope. So shouldn't that be negative towards that? That slope is that a positive? Should be like it's.
So this would be a negative slope of v.
Yeah.
Do you agree?
Yeah, that's it.
But it's positive slope of this.
Oh, okay.
Do you remember that? Oh, good. He sees it.
Got it.
Doing a great job with that. All right, let it read. I'm gonna put a star in this guy. There's so many ways to look at this. When is the particle speeding up? So I desire to give everyone an easy way to solve this. And I'm going to tell you what I recommend. I was just discussing this with my pre-calc students. Who takes physics? Anybody know the definition of speed?
Distance.
I heard it. He's a physics. There we go, Bell Rise. Magnitude of what?
Of velocity.
That's right. Someone, would you put this down? Speed is magnitude of velocity. Speed is magnitude of velocity. Would you put that down somewhere? If we know this, I think this problem is going to be a piece of cake to solve. There's other ways to look at this. That is. Magnitude meaning like the size of it, and we're going to keep it positive. Speed is always referenced as a positive number. And when I was going 55 miles per hour on Route 50 East, then I was going 55 miles per hour on Route 50 West. I was going in a total opposite direction. I'm not talking about velocity, I'm talking about what word? Speed. You go, but isn't that velocity? It's the magnitude of velocity. Cool. But like you said, Josephine, oh, so it's just the absolute value. So I think the easiest way to answer this question, if speed is the absolute value of velocity, why don't we just graph speed and look to see when it goes up and down? You go, I don't know how to do the absolute value of this graph. I'm going to do it right below it, okay? So right below this, there's enough room for me to do this. What would the absolute value of velocity graph look like, which references the speed? If you've never done this before in a pre-calc class, trust me, it's real easy. What I need you to do is recopy this entire graph perfectly. But if anything goes underneath the x-axis, I need you to reflect it up here. Okay? That's how you graph an absolute value function of any expression. So watch this. Is this up here above the x-axis? Then I'm going to do the same thing. La-da-da, la-da-da. There it is, 36, coming down. And what number is this? 2. And what's this number over here? 6. But since it's the absolute value, see this part right here? It's going to get reflected up here like that. So it's going to go like this, look. Woo! And come back in. And then past 6, what would this do?
Go up again.
I am telling you, everyone, I find this the easiest way to answer this question. Because now go look at, this is your speed graph. Look here. Look, I'm slowing down. I'm speeding up. I'm slowing down. You follow me? So can you answer the question now? Look carefully at all those numbers. Right? When was it speeding up? From 2 to what? 2 to 4. Anywhere else? Where else did it speed up? 6 to infinity, but we only went out to what?
10.
That's when the particle sped up. Like, you know, speeding up. Now there's other ways to do this. But I'll tell you, I don't recommend them just because of grading the problems over the years. Somehow that gets people. What's an easy way? Look at the what? Look at the speed. Look, up, velocity. Now some people say, oh, if your velocity is negative and your acceleration is negative, and they have all these other tricks to do it.
Where there was a positive.
That's right. You know, let's put letter F, but no one misses this. Can you come up with a formula for acceleration?
Yes, 60 minus 24.
So acceleration is the derivative of what? Velocity, where's velocity?
3t
Way
squared.
back at letter A.
Yeah.
Everyone, what's the derivative of that velocity? 3t squared becomes 6t. And when you can call this a of t, does that sound good? A of t and minus 24? Does that work? No, great job. All right, let's find another good one in here.
How'd you get the formula again?
Oh, over here? You'll find this real easy. So remember how we're talking about position, velocity, and acceleration. And the derivative of position is velocity. Derivative of velocity is acceleration. S prime t, S double prime t. Cool? So, velocity was derivative of position, and then how can you get acceleration? It's the derivative of what? Well, it's the rate of change of velocity. Oh, just simple derivative. What's the what do people miss? This. And I think it's easy if you just graph the what? The speed function. So, slow down, speed up, slow down, speed, right? I know. All right, everyone. Let's go to page 234. Let's try number 9. Now, I might not answer every question from 3.7, so when you come in tomorrow before we do related rates, let me make sure I do any problem from this section, or any problem from 3.6, or you still might have an old chain rule problem, right? You might have an old chain rule problem. Here it is. Now, what do you got? This is number 9. And when a rock is thrown vertically upward from the surface of Mars, okay? Its height after 2 seconds is this. And this is the height of this rock. For what planet?
Mars.
Mars, because if this is Earth, we all know gravitational pull. All of you, and you'd be like, Professor Messer, your math formula is incorrect. This is on Mars. All right. H equals 15t minus 1.86 t squared. Letter A and letter B. I think letter A is going to take everyone in this class like a minute to solve. Letter B, not hard, just a couple minutes. We'll be able to wrap up. Letter A. Everyone, what is the velocity of the rock after 2 seconds? What is the velocity of the rock after 2 seconds? Anybody know what I should do?
Yep.
First of all, do I plug 2 in here?
No.
No, that's height.
No, you
Plug
do.
in.
How do I get velocity? I get the what? Derivative. You want to call it v of t? So I'm going to write v of t. And what's v of t equal to? We can call velocity v of t. That's h of t.
Can I do H?
Position, right?
Yeah, can I do H prime t?
He says you can write it as h prime of t. I love it. H prime of t is v of t. True?
Yep.
Good job, Art. And you get 15 minus, what's that derivative?
3.
3 point what? 7 2? Is that right? 7 agree? Cool. Now how do you find the velocity of 2?
Plus just put
Use
it
22.
2.
And what's good notation? V of what number?
2.
Or as you said, Arch, h prime of 2. Did you know your calculators have a derivative button where you just say, take the derivative of this at 2. Did you know it could do that? It's math 8. But you'd have to type in this and put letter x, put comma x, and then say comma 2. I'm serious. Math 8 will do that. It doesn't give you the derivative expression or formula, but it'll differentiate at a certain value. Cool? If you want me to show it to you, I'll show you tomorrow at the end of class. Now, and what is v of 2? What's 15 minus?
7 point something. 7.34.
7 point what? So what's 15 minus 7.34?
So that's 8.66.
7.56.
7.56. Sorry.
Now let's go back and see what the units were for this problem. They have to tell you. T was in seconds,
Meter per second.
and height was in meters.
Is it 7.34 or 7.44?
7.44?
7.
Was this 4.4?
Yeah.
Yeah, 7.44. Yeah.
Josephine, thanks. But this is still what? 7.56. And what's the units? Meters per what? Is that okay with this? But yeah, hey, if anyone's curious here, math 8. You tell the calculator, you type this in, and then you go differentiate it, time equal to 2. and it'll give you that number. Let's do it for you. Cool? But that wasn't hard, right? We don't need that button. That's why I really use it. Letter B. This is interesting. Listen to this. Hey, last question. What is the velocity of the rock when its height is 20 feet to 25 meters on its way up? So what is the velocity of the rock when its height is 25 meters on its way up? Why do they say on its way up? Because when someone threw the rock, what happened? How many times did it reach a height of 25 meters?
Once.
Once, twice. Does everyone agree?
Mhm.
That's what's happening on Mars. The rock, it hit 25 meters on the way up, and then it hit a height of 25 meters on the way down. They're saying, could you find the velocity of the rock when its height is 25 meters on its way what?
Up.
Up. First step, I was wondering if someone can help me out with this. What's the first step here? I'm going to set 25 equal to something. But read the problem carefully. It's not too bad. When word problem, would you read it carefully? What am I going to set 25 equal to?
H.
H.
Uh-huh.
You all agree? Excellent. Good word problem solvers right here. You see it. Like, all right, height is 25. So go back to height. But I'm curious. Here we go. I'm looking at you all. I'm thinking, how do you want to solve this? Are you,
You want to solve for t.
yeah, because you want to solve for t? And everyone, we're going to get two answers for t. Do you know that? See the quadratic?
We can't get it right.
But you won't be able to factor this, so we got to use what formula? Quadratic formula. But if you're like me, everyone, we're now in calculus. This is an application problem. If you like to sit there and do your negative b over 2a plus or minus the square root of b squared minus 4ac over 2a, you want to do it, you can. But I like to solve this with a calculator.